using measurement devices to record horizontal distances and vertical elevations. Triangulation is based on a single principle of plane geometry. Distance between 2 points can be measured by modern electronic distance measuring equipment. In some cases, it may be measured on the ground by tape. Angles between 3 control points are measured with an instrument called a theodolite. Observations are carefully recorded in the field surveyor's notebook for use by the map compilers back at the base. Identification of each point is especially important. To this point, the surveyor has been establishing only what is known as horizontal control, the position of control points in a flat plane. To determine the elevation of these points, he does what is called leveling. The surveyor starts from a basic control point called a benchmark, where the elevation above mean sea level is known. He sights through a leveled viewer at a measurement rod held on a second point. He can see how much the point is above or below the basic control point. He may also use an altimeter similar to those used aboard aircraft to determine their altitude. He records time and temperature to be sure the reading is absolutely accurate.
What is triangulation in surveying? Triangulation is a method that is followed in surveying to achieve horizontal control. In triangulation system, a number of interconnected triangles are traced and measured to determine the relative positions of the points that is spread over an area. In this system, the length of only one line is determined, which is called as the baseline, and the other angles and length are deduced by the observation from this baseline. Triangulation system in surveying. As mentioned, a series of interconnected triangles form the survey area. If we know the length of one side and the 3 angles, the length of other sides of each triangle can be computed. In the system, the apex of the triangle are called as triangulation stations, and the whole figure is called as triangulation system or triangulation figure. Now, the figures used for a triangulation system can be either triangles, quadrilaterals, or polygons. All the figures that are used in triangulation system for surveying must follow certain conditions, which are: the sum of the interior angles should be 2n-4 into 90, where number of sides of the figure is given by n. The total sum of the angles joining at a station must be equal to 360 degrees. The length of the sides that are calculated through more than one route should match and degree to this. Triangles for triangulation. Among all the figures, triangles are the most commonly used figure for triangulation system because they are very rapid and economical when a narrow strip is to be surveyed. The triangles used for triangulation must not have interior angles that are less than 30 degrees and greater than 120 degrees. This is method which is more economical, simple and rapid. But as it is used in a long narrow strip, number of baseline is introduced frequently that would result in the accumulation of errors. Hence, it is less accurate. Quadrilateral for triangulation in surveying. This is an excellent figure system which can involve various combination of sides and angles. It can be used to compute length of required sides and checks can be made frequently. The best quadrilateral which can be used for triangulation system are squares. A quadrilateral with both diagonals without no station at their intersection are also followed. Quadrilateral figures are used in triangulation for hilly areas. It involves more number of checks, hence the method is more accurate. Polygons for triangulation. For areas that are very wide, their length is surveyed either by a pentagon or a hexagonal area. This option is more economical compared to triangles when wider area is there. So in case of polygon figures, they may or may not have a central station. It involves more number of checks compared to other figures opted, hence the method is more accurate.
Hey, listen, give us a quick rundown on how we measure things.
We measure things with horizontal distance.
Horizontal distances, right? Never factor in any curvature?
I don't. I don't. Everything I do is angles and distance.
That's
and
it.
We base everything on trigonometry, which is all right angles. And of course, if you're doing topography, there's slope distance, but that's not the same as spherical trigonometry.
I'm talking about like when you denotate a property line.
Yeah, it's all horizontal.
It's all horizontal, right?
All horizontal.
No matter how big, right?
The assumption is
if you're going to do a golf course, are you going
just
to...
like airplane pilots, the assumption is that you're flying over a flat plane. We are assuming, and it's more than an assumption, that we are working on a flat plane.
It's more than an assumption with us because that's exactly how we do it.
Right.
Horizontal distances exclusively. Somebody wants to know the distance between 2 points, it's going to be a horizontal distance.
Yep.
No matter what the topography is.
Absolutely. Absolutely.
All right.
Absolutely.
Let's
And
get
this
to work.
machine here does not take into account 8 inches per mile squared.
Not at all.
Not at
From the reenactment of an historical ceremony to a place where history is always being repeated. Here at a famous North London firm of geographers, 60,000 globes of the world are made every year. How the real world began has always been a fascinating study, but there's a set method of world making at these workshops, a complicated craft dating back to 1492 when the first known globe was made. Round a solid ball of wood is built up a hollow shell of stiff paper, which is then coated with plaster. Nine separate layers of plaster are applied to a thickness of 1/8 of an inch. Moulding takes about 6 hours, and a fine, smooth surface is imparted to the world in miniature. Once the globe is set and dried, it passes to another department where the covering map is pasted on. Like restoring the skin to a peeled orange, the colored printed sections exactly cover the surface. But the covering process calls for a keen eye and steady hand. A fraction of an inch out will put the world miles out of joint. The globes come in a large variety of sizes and purposes, from an inch in diameter to 6 feet, and ranging in price from 16 shillings to £1,000. The different types of globe include celestial, political and relief, or slate-colored spheres for use with chalks. In keeping with their subject, the globe makers have a world market. 90% are made for export. They're printed in all languages, including Russian, and the majority go to schools. From first to last, the complete job takes 15 hours. A final coat of varnish adds a protective shine. Nearly 100 of the staff have been there for more than 30 years. While the rest of mankind does its best to blow the world up, they like building a new one.